Hello, I'm Dan Gross. I'm from Team Sure Controls, and I'm going to go over our overall design and the final design of it. Um, so, in the last few weeks, our design has gone through a number of iterations on a number of the different components. What you see in front of here is a front view of the overall assembly and a back view of the overall assembly. We did not currently load in a lot of the components that are in there just due to time and but we've verified with pictures that the components that we've added do not interfere with any of the existing components on the machine. In the center here, you'll see a new winding path layout where we have actually moved one of these idler rolls to this upper location for the pre-nip idler. And then this is the dancer arm, which is controlling the speed of the first roll. And then this is the load cell roll, which is controlling the speed of this driven roll here. And then lastly, they have another transducer to control the speed of this last one. Um, and that's already built into the system. So the overall frame height ended up being about 71 inches in total height, which our design constraint was 84 inches or less than 7 feet. That brings us into the motor mount. So the motor we had a tough time finding the actual CAD for the motor from Marathon Electric that they are currently using with the system, but I was able to find an actual drawing of the motor, so we were able to take the dimensions off of that and then lock in this upper pulley assembly in relation to these bolt holes to simulate kind of where that shaft would be eliminated or coming out of that motor with these existing holes. So that's why where those features are coming from. So based off this current setup, we have selected that we will need about a 36. We'll need this timing belt from McMaster, which is 36 and a 0.7 inches in circumference, and that will drive from the motor to this driven roll using the timing belt pulleys, and then those are keyed into the shafts, also the motor shaft and the driven roll shaft. And we'll get into those details in a little bit. But for the motor mount, to tighten that timing bolt, we've given the Sure Controls over 2 inches of side-to-side movement. As you can see, 1 inch for slots on the top mounting plate, and then another 1 inch with slots on the actual tightening the actual mounting bracket. So we believe with those 2 inches, that should be plenty, if and significantly amount of room to tighten in that belt over time as it loosens or wears before replacement is necessary. That brings us to the driven roll assembly, which we briefly touched on, has that the belt-driven pulley, which is attached to the shaft with the keyway, and then that has 1/4 inch keys, which are about 1 inch long on both ends, so that way it doesn't go all the way through. It's just easier for assembly purposes. And then as you see on the right here, there's actually a set screw to lock down on both of those keys to prevent this outer driven roll to move while actually functioning. So this driven roll has a 2-to-1 transmission through the pulleys, which is similar to their current design, and it was just a duplicate of what they currently had in the system. And then that will bring us to the nip assembly of the machine. So this area took probably had the most complexity to the design that we had in the system. We had to redesign these arms a few times to actually get them to function with the movement that we needed. We are confirming with Sure Controls that this opening is acceptable amount. If not, we will be planning. So they had originally set that we needed a 4-inch opening. So this is about 5/8 of an inch too shy of that design constraint. We can increase to that 4-inch opening, but we will have to move the mounting holes for these pivot mounts down about 2 inches, and that will cause that to be actually drilled into this big frame plate on the backside. So we've proposed to actually mount it into the new mounting plates instead, but we're confirming that with Dale at Sure Controls to make sure that that is an okay with them. If not, we will move it to make sure that we have that 4-inch opening as needed for final design. So as you can see on the right, then this is the new winder layout. Like I had mentioned before, we will have to relocate this pre-nip idler, which will be removed from down here. That is already existing on the machine, so it'll be something that we can remove, and then we'll just have a single bolt or a 4-bolt pattern on the backside, which we are waiting from Sure Controls to finalize that this week. And then lastly, that brings us to the load cell roll assembly. Sure Controls had decided that they want to go to a different manufacturer for load cells, and this is actually just a single load cell then that is mounted onto a cantilever beam, and it is made by Dover Flexo Electronics Incorporated, and so it mounts to the existing frame with a 5/8 11-inch thread bolt, through bolt, and then that just gets clamped onto the existing frame. So that'll be one more hole that they'll have to drill into the existing. But there's a chance that we may be moving this within this week to try to improve our wrap angle on this last roll. And then I believe Zach will take us through the FEA analysis on a lot of these components. Thank you.